This is chapter 1, an introduction to Java and the start of the course. As you can see here, there's a picture of the book, the 9th edition. You can also use the 8th or the 7th edition. The contents are pretty much the same. Now, the focus of the course is object-oriented software development, which will include problem solving, some program design, implementation and testing, and we'll also be looking at some object-oriented concepts, including classes, objects, encapsulation, inheritance and polymorphism. Now, some of these terms will sound a little bit weird at the moment, but as we move through the course, they will become clear. The other thing we'll be looking at and discussing all of these things through is the Java programming language. So here we'll start with the fundamentals of computer processing, and in this chapter we're going to be focusing on the programming and programming languages, an introduction to Java, and an overview of object-oriented concepts. Now there'll be 3 videos in this section, one for each of the bullet points that I've just outlined there. So, the Java programming language. What is Java and when was it created? Well, it was created in 1995 by Sun Microsystems, and it grew very, very rapidly, and specifically it was used a lot on the web in the early days, but now it's all pervasive in large areas of life. So what is a programming language? All it is something that specifies words and symbols that we can use to write a program, and that program then can solve some problems. It employs a set of rules that dictates how the words and symbols can be put together to form these valid program statements, which in turn eventually will solve our problem. The Java programming language is made up of one or more classes. Okay, it contains one or more methods, and a method contains program statements. All of these statements above will be explored in more detail throughout the course, and by the end of the topic you will understand and be able to write classes, write methods, and write statements within those methods. A Java application, i.e. something that we will write a program to solve a problem, always contains one method called main. And this will be evident as we have a look at the Lincoln.java program as an example. So here we have a structure or a program that is going to print out a couple of statements, a quote by Abraham Lincoln. You'll notice it has these statements here: public class Lincoln, a curly bracket or a brace, some comments, which we'll have a look at later, and then we have our main method here. And you'll notice the header for this method: public static void main string args. At the moment, all you need to know is how to type that. The rest of these statements will become more and more apparent as we move through the topic. We have another brace, and then we have some program statements: system.out.println, and then some brackets and a string in quotation marks, followed by a semicolon here, and then another line pretty much the same as the one above, system.out.println, and then another string that says whatever you are, be a good one, and another semicolon. Then we match the braces. We match this brace with this brace, and this brace with this brace, and that constitutes our program. So when we compile and run that, we should see some output. And that's the output that we see. A quote by Abraham Lincoln, "Whatever you are, be a good one." So here we have what the structure looks like. Here we have comments about the class above it, public class my program, which is called the class header. The class body is written inside the matching braces here. And as it says here, comments can be placed almost anywhere as long as we use the syntax here, double forward slash here. There are some others that we'll explore in detail a little bit later, but safe to say that is the first thing that we're going to do when we write a class. We're going to give it a name, public class, whatever the name you want, my program. We'll look at some rules on how we can call variables or call names later. And then we have a set of braces in which we will write our program. Then we're going to put in a method header, comments about the method above it. And in our case, for our simple programs, our method is going to be public static void main, a bracket, string, 2 square brackets, name args, and then another bracket. Then we're going to put another matching set of brackets, and we're going to write in here our method body, i.e. the program statements that we are going to employ to solve our problem. As I said before, we can put comments just about anywhere in our program, and typically they're used to explain the purpose of the program and to describe any processing steps. Now, you don't have to put comments for every particular statement. If the statement is obvious what it's going to do, well, therefore, we're not going to actually put a comment there. So really, the comment should be there just to effect and tell the reader anything that sort of looks a little bit untoward or looks a bit different and it's not really clear what you're trying to do. Having said that, you should always put a comment at the top of your program, and you should always put a comment before any methods that you write. They don't affect how the program works, so feel free to put as many in there as you wish. Now, there are 3 forms. In the previous slide, we saw the first form, the // and that only runs to the end of the line. If you want to put something on a new line using this form, you'll have to put another 2 slashes. If, however, we've got more than one line, maybe 2, 3, or 4 lines, we can start our comment with a /*, write as much as we want, and then put a */ at the end. And whatever we put between the /* and the / will be treated as a comment, and as many lines as you want, even with empty lines between our comment. The third type here is a special type of comment. It's called a JavaDoc comment. That enables us to use a little program called JavaDoc that generates some HTML pages about our programs. And a little bit more about that later. So what about some identifiers? These are the words in the program that we can use to name variables, or we can use to name classes, we can use to name methods, and those sorts of things. Now, there are some rules here. They can only be made up of letters, digits, and the underscore character and the $sign. However, having said that, identifiers cannot begin with a digit. So therefore, we must be using either an underscore or a letter or the $sign to start the name of a identifier. It's also case sensitive. So those 3 versions of total there, total with in title case, in lowercase, and in all uppercase, are all treated as different identifiers. Now, lots of things happening here, so we can, choose our variables in any way we like, or in our identifies in any way I like, but there are some sort of unwritten laws and unwritten rules about how we actually use the different types of writing to different types of identifiers. So class names always start with a capital letter or title case. Anything that we're going to use as a constant in our programs, and we'll be talking about those a little bit later, they are always in all uppercase. Method names are usually all in lowercase. So if we follow these rules, then we'll be able to read anybody's program and understand what type of identifier we have in their program. Now, sometimes we choose the identifier, such as in the Lincoln program. Sometimes we use another programmer's code. So we use different identifiers that they chose, such as the println statement that we had in our program previously. There are some other things that we use that are called reserved words. They already have a predefined meaning in the language, and each language, other than Java, there might be C or C++ or whatever Java, Python, they have a special meaning in that language, and we can't use them in any other way than the meaning that was predefined. So let's have a look at a few reserved words. Wow, lots of them, isn't there? Okay. Some of these we will be using throughout the course of this topic. Others, like goto and things like that, we will not. However, having an idea of these sorts of words gives you an idea of the size of what we can actually produce and how important it is that if we see a message saying, oh, you can't use that word, it's typically going to be because it is a reserved word. So no need to memorize all of these. Some of them you'll get more and more familiar with as we go through the topic. However, safe to say, quite a big list, and let's not get bogged down on it. So what about making our program look readable or make it easy to read? Any sort of blank lines, tabs, spaces, things like that are called white space. Pretty straightforward, that. We use it to separate words and symbols in a program, just as the same as we do when we write words to write an essay or a letter or something along those lines. Any sort of white space in a program, though, is ignored. So you can have 16 spaces between two identifiers, or you can have one, and it won't make any difference to the way the program is interpreted, just to the way it's read. So therefore, you can format it in many different ways, and the best way we can do that is to enhance our readability using a consistent indentation. Now, as we'll see in a while when we look at the JGrasp environment, that enables us to actually, it has some pretty cool features that enables us to indent and format our programs at the touch of a button. This is evident in most integrated development environments, including Eclipse and NetBeans. There are shortcut keys and ways to format your code so that this is done for you. So you don't have to remember to do it yourself. However, having said that, it is always good to use these shortcut keys and use the available formatting options within a program or within an IDE to make your program readable. Let's have a look at some. We'll have a look at Lincoln 2 and Lincoln 3, which are available in the folder for week 1 or for module 1. Please avail yourself and have a look at those at the different formatting. They all produce the same output, however, they just look a little bit different. Okay, so that's the end of this particular section. The next video will be on the next section in this chapter.